research at the relational expression. Then the next thing is we can convert this one into database language that we are going to learn the next class. Okay? The next example. Retrieve the name of employees who have no dependent. First, you need to understand the meaning of the query. What does that mean? Retrieve the name of employee who have no dependent. Suppose that we are the employee. I have dependent. Am I belonging to that? No. He is employed, but he does not have any dependent. Then can it be? Yes. So that is the meaning of this query. Then, before you see the answer, think about how can we access such an employee who does not have employee.
First, from implied table, we access the SSN, and from dependent table, we also get the ESSN. Then we will subtract from the implied table to the dependent table. Then we get the.
So, in other words, so he's correct. So, can you understand? Oh, probably not. The end. So, think about. So, we have employee. Some of them has dependent, the others are not. If you try to get the employee who does not have the dependent, it's a little bit hard. Right? Why don't we change the question? Names of employee who have dependent. Very easy. Right? Dependent table has the ESSN. You can retrieve that one. That's it. Then how can you get this employee is dependent, having dependent. These are not. So we have list of employee, social security number. How can we get the other? Complement.
Yes.
Difference. So whole employee, why don't you subtract who has the dependent? Like this. So this is the employee. No dependent. Yes, dependent. We have the list of employees who have the dependent. Why don't you subtract this one from employee? Then we can get this. Right? Then we can convert this idea to the relational expression. So, first one. What does that mean? All employee. That is this. In Venn diagram, this is the all employee. Then, what about this? This is the ESSN having dependent. So, this. How can we get the other? Subtract. All employee minus. At this time, you should be careful what? Type comparability. Okay, when you use such a subtraction, the type should be comparable. That is the reason we retrieve only social security number. We retrieve the social security number projection. It's the same domain, same. It's a type comparable. Then subtract. Then we can get only this one. But question is name of employee. How can we get the SSN? Using SSN, where can you get employee information?
Implied table.
Using employee table. So that is the reason we can join. Actually, this is a natural join. We can change this one. Join with, this is the ESSN. Here is a rename, SSN. Equal to SSN in employee. Okay, we can use such a join operation. Then finally, we can get this. That's the whole thing of the relational algebra. The next one is a relational calculus. However, I'm not going to introduce a relational calculus, but I'd like to emphasize on what is the main difference between the relational algebra and calculus. Both the relational algebra and calculus show how to access the data. Okay? However, relational calculus more focus on more in the output, only the condition. For example, right? Can you remember the elementary math? Like how many different ways of the representing set? So sometimes you can list up all the value 1, 2, 3, or sometimes you can use the condition. X bar X. X is natural number.
Yes.
Like this. Both of them are fine. So relational calculus used this way, this method. So it shows only the condition. Okay? Why? Relational algebra actually show, as you can see here, step by step. Okay? First, access department, then join, then project, this one. First, access employee, then access the dependent, then subtract, then natural join. So relational algebra output is the same. Relational algebra, relational calculus are the same. There's no difference in terms of output. However, the relational algebra is focusing on how to way of access the data, step by step. Why relational calculus show the condition, entire condition only. So in DBMS system, as I suggested, as I mentioned many times, when I go to Manhattan in New York, how many different ways? Too many different. You cannot count all of them. Sometimes I can visit the local road and millions of the way. But you try to find fastest way, like your GPS system. There are many options to route the way. So usually I like the fastest way. It considers several conditions. Similarly, DBMS system actually used only one way among bunch of different possibilities. At that time, DBMS used relational algebra expression. Why? Because we can see clearly the step by step. That is the actually query tree, this one. We can use the tree structure to represent the way of access the data. Like for example here, first the project, then the selection, then join, and join, then projection. Actually same as the previous one. So DBMS system utilizes such a relational algebra operation, expression, that is called the query optimizer. So query optimizer used such a relational expression, okay, algebra expression. So I'm going to skip this one. Finally, we can use select from where. Have you ever heard about such a select from where clauses? Yeah. Yes, I think most of the students, if you are majoring in the computer science, you have seen the select from where, very well-known famous database language, right? Let's compare with the relational algebra operation that we learned. What is this? Select condition, right? You can limit the certain data. Actually, that is implemented here, where condition. What about this? It's a projection. You can limit the specific column. It's implemented here. Then, what else? Rename. And this.
Yep.
This rename column implemented here, that is called alias. We will learn in the SQL. Also, this rename is implemented here. It's an S. It's an alias also. What else? Union, intersection, minus, they are implemented. So we need two sets of select from where, select from where. We can union we can intersect, we can minus. And what about the join? Join is implemented in where condition. So where condition, two condition. One is the selection condition, another one is join condition. And any types of the join, actually here, aggregate function. That is additional group by clauses. So we will learn such a thing in SQL chapter 4 and 5. Finally, we move to the SQL, structured query language. Okay. So before that, for your exercise, so this is a homework, the fourth homework. So you can make the using the company database that I hand out that you have. So you can create the relational expression for each question. For example, the last one is a list the names of the department manager who have no dependent. It's a little bit different from the example that I show you. This is the names of department manager. Okay, quite similar. But why don't you make the relational expression? It doesn't matter whether you can have the one big combined relational expression or step by step. But as long as you follow the rule that we discussed. Okay? The same thing, you can bring the handwritten homework next Thursday. Okay, then SQL, structured query language. So, what is the language? Program language. Program language is the communication tool between me and him, computer, as a computer, right? So just like even though we are from the different country, different languages, but we can communicate because we are using the same common language in English. Similarly, computer can understand the program language. Also, I know how to use that computer language. So using through the computer language, I can order to do something. Okay, to utilize the computer resource, especially in the database, I'd like to use, I'd like to access, I'd like to manage the data through that computer language that is called the structured query language. Also, that structured query language, SQL, is based on what? Relational model, relational operation, relational expression, and relational calculus, relational algebra and calculus. That is the SQL. However, SQL is a little bit different from other program languages. Other program languages actually start from start and define some value and sometimes condition and then end. Right? So sometimes go to and so on. There are many conditions. It's called a procedure. It's a procedural language. On the other hand, the database language, I show you one example, select from where. Does it have any starting? Does it have any ending? Does it have any condition? Does it have any definition? No. It's just a structure. It's a model. We just follow the relational model structure. That is the reason it's called a structured query language, SQL. It's different, totally different from other program languages. Actually, SQL is the only way to access the database. Is there any other way to access the DBMS? Yes, you may be. If you are using the something LINQ, for example, it's kind of a component to access the database. However, inside this component, it uses SQL language. The reason is that, as I said, SQL is the only way to access the database. Since SQL is different from other program languages such as the C#.NET. I'm very, very familiar with the C#.NET or ASP.NET, but that doesn't support database language. Why? Their model is different from relational model. It's totally different model. So we need to combine program language plus structured query language, database language. We need to use two languages. That's the difficulty. Just like the oil and the water. Can it be mixed? No, they cannot be mixed. They are totally different. Just like that, SQL and program language are totally different family. So they cannot be mixed together. That is the reason we need to learn database programming separately. However, because of that, it's difficult to use both database language and program language. We try to hide accessing the data. Why don't we make the kind of a library? Why don't we make the function? Why don't we make the component? We forget about how to access the data, or a very simple way. Then inside, why don't we use such a library to access the data? That is the reason sometimes you forget. You don't realize how to access the data. Just use the database command or the language as if you are using the local data, memory data. Okay? However, sometimes when you are using such a component, if you do not know how the database query language is working, when you encounter the problem or it does not have the flexibility. Okay? So that is the reason I do not focus on a lot of this part. The program language you will learn in other class. But this class I'm going to focus on the database language part. That is the SQL. So, however, many people realize this database query language SQL will be very, very powerful tool. However, if we let each individual or company develop the database language, so we have one database language, the other database language, another database language. If there is no common thing, we need to learn this one separately, just like the program language. So if you know how to code the Android, it's the same as the iOS. It's different. You need to learn which library. Their architecture are different. Okay? So this is actually good news. So many people actually get together. Long time ago, 1986, they decide, why don't we make the standard of the relational database language? So they make some common function. This is the first standard. It's called the SQL 1 or SQL 89. Then, as long as the DBMS software follow the standard, this is called the SQL or relational database. Then that means if I can use one DBMS follow this standard, they are not much different from other DBMS. For example, I learned the first time database language based on the Oracle. So Oracle 6 and 7. But when my company merged in other bank with the other bank, that bank actually used the Infomix. But it's not much different. Almost the same query, same function. So we can easily merge and run, catch up the other DBMS. It's the same thing for you. If you are able to use the Oracle database, but when you get a job, if your company uses the Infomix database, it's not much different. So you don't have to worry about it. So because of the standard, that standard has been improved. And the SQL 2 is the major revision. Most of the current the relational DBMS system follows SQL 2. And then SQL 3 add the more specific function like the recursive query and trigger some object-oriented concept. Unfortunately, from 2003 up to the SQL 3, SQL 1, 2, and 3 are free to use, which means I can develop the relational database management system, then I can sell it because it's a free standard. However, from SQL 2003, Oracle and some major vendor, they lead the market, then they decide from now on this standard is not free. In other words, even though I developed the DBMS based on this SQL 2003 standard, I need to pay license to that group. That is the reason still the Oracle and major vendor, Oracle, DB2 in IBM, Infomix is also IBM, and Sybase and SQL Server in the Microsoft, they are leading company. There are not much more the market share DBMS or the company. Even educational purpose, we cannot use the new standard instead up to the SQL 3. Okay? So this is the overall the history. So our class will focus on the SQL 2 and 3, mostly SQL 2, some additional feature in SQL 3. Okay? So next class, as I announced the beginning, we will have another lecture on Tuesday, not the exercise lab. Then on Thursday, we will have the exercise lab in Tech 163. So please keep the section that you assign. Okay, otherwise one of the section will be full of the students. Okay, and any question? So we do not have the midterm on the before the spring break. Instead, we will have the midterm probably end of the March, not canceled. So end of March. Okay. You can check anytime the latest information about the revised schedule on class website. Thank you. And so I think that you need to submit the homework today.